If you've ever fired up a new 2D project in Unity, you know the drill. You start with a simple circle, maybe a square, just to get your player moving. And hey, it works, but well, it's not very exciting, is it? So in this explainer, we're going to ditch that placeholder ball for good. We are going to build something way, way cooler. We'll start with a totally empty object and, piece by piece, assemble a complete, multi-part snowboarder character, getting him totally prepped for the game's physics.
So what's the game plan? Well, here it is. First up, we're going to prep our main player object by just ripping out all those old placeholder components. Then, the really fun part, we'll build our character, let's call him Barry, by piecing him together from separate body parts. After that, we'll dive into the super crucial step of aligning everything so he actually looks right. And finally, we'll make him real, give him a physical presence in the world by setting up two different kinds of colliders. One for his snowboard to ride on the snow, and one for his head for crashing later on. Let's get to it.
All right, section 1 it is, replacing the placeholder. Look, before we can even think about building our cool new character, we need a totally clean slate. Right now, our player is still a ball. It looks like a ball, it collides like a ball. This first step is all about demolition. We're stripping away those old parts to create a clean, empty foundation that we can build Barry on top of. Okay, let's get our hands dirty in the editor. First things first, find that ball object over in your hierarchy window. Go ahead and select it. Now, look over in the inspector. Right at the very top, just click in that name field and let's change it to Barry. Easy. Now for the cleanup. See this component called Sprite Renderer? That's the thing that's drawing the circle image. We've got our own art, so we don't need it. Let's just click the little 3 dots on the component and select Remove Component. Gone. Next, the Circle Collider 2D. This is what gives the ball its physical shape. We're going to create our own custom colliders later, so we can get rid of this one too. Same deal, click the dots and Remove Component. So, take a look at what's left. I know, it might not look like much. In the scene, it's literally invisible. But this is perfect. This is exactly what we want. We've intentionally kept the single most important component here, the rigid body 2D. Think of this as the physics brain for our character. It's what handles gravity, mass, velocity, everything. By keeping this, we've basically created an invisible physics core that we can now start dressing up with our character's visuals. Okay, our foundation is poured and ready. Now for the really fun part. Actually building Barry. See, he isn't just one single image. He's made up of a couple of different pieces that all need to move together as one unit. And to make that happen, we need to get comfortable with a really fundamental concept in Unity, and that is the parent-child hierarchy. This idea sounds technical, but it's actually super simple and incredibly powerful. The best way to think about it is like a puppet. Our main Barry game object, the invisible one with a rigid body, that's the puppet master. That's our parent. Every visual piece we attach to it, his legs, his torso, becomes a child. It's like a limb on the puppet. So if we move the Barry object, all the child pieces, the limbs, they all have to follow along. This is the secret to making sure our character moves, rotates, and even scales as one single coherent thing. All right, theory's over. Let's actually do it. I'm going to go down into my project window and find the sprite for border bottom. That's his legs and his snowboard. Now watch carefully. I'm just going to click and drag this sprite and drop it right on top of our Barry object in the hierarchy. See that? See how it just snaps into place and it's slightly indented? That little indent is Unity's way of telling us, hey, this is now a child of Barry. Perfect. Now let's do the exact same thing for border top, which is his torso. Drag it, drop it onto Barry, and just like that, he has 2 children. And the second you do that, you're going to see a problem. Take a look in your scene view. The body parts are all over the place. They're not connected at all, they're just kind of floating out in space. This is a super common thing that trips people up when they first start working with hierarchies, so if you're seeing this, don't worry. But what's actually going on here? Here's the key thing to understand. A child object's position isn't measured from the center of the world, like you might think. No, it's measured as an offset from its parent's center. So when these sprites were originally created, they had their own position data baked in, and Unity is trying to be helpful by preserving that offset. To fix this, we basically need to tell Unity, hey, ignore that old position data, just snap this thing to its parent's center. We need to reset their local position to 0. Okay, time to solve this alignment puzzle and finally put Barry back together. In this section, we're going to do 2 things. First, we'll snap those floating body parts back to the center where they belong, and then we'll do some fine-tuning to actually assemble our snowboarder so he looks like, a snowboarder. And you'll be happy to know this is a really easy fix. First, just select the border bottom object in the hierarchy. Now look over at its transform component in the inspector.
See the position X and Y? They've got some weird numbers in there. Just go ahead and set X to 0 and Y to 0, and bam, it snaps directly to the parent's center point. Now let's do the exact same thing for border top. Select it, set its X and Y position to 0, and now both parts are perfectly stacked right on top of each other. Okay, they're centered, but now they're just a jumbled mess. Let's fix that. I'm going to select only the border top object. You can hit W on your keyboard to bring up the Move tool, and now I'll just drag it straight up on the Y-axis until it sits nicely on top of the legs. That looks about right. Now, for a super important pro tip that will save you headaches later. See this little gizmo right here? That's the pivot point for our main Barry parent object. If we were to rotate Barry right now, he'd spin around his feet, which would look really weird. We want him to rotate from his center of mass. So to fix that, I'm going to select both child objects at the same time. Just hold down Shift and click them both. Now, with both selected, I'll use the Move tool to drag them down together until that parent pivot gizmo is right in the middle of his torso. This is going to make all our rotations look way more natural later on. Awesome! Barry is all put together. His pivot point is right where we want it. Let's give this a quick test. I'm going to go up to the top of the editor and hit that play button and whoa, where'd he go? Okay, he fell, but he fell behind the snow. This has to be one of the most common issues you'll ever run into in 2D game dev, and thankfully it has a really simple fix that has to do with something called render order. So here's the deal with how Unity decides what to draw on top of other things. By default, pretty much every sprite in your scene has an order in layer value of 0. And if two things have the same number, Unity basically just shrugs and doesn't guarantee which one will be on top. To fix this, I'm going to select both of our character sprites again. In their sprite renderer components, you'll see this little field called Order in Layer. By changing this from 0 to a higher number, it doesn't really matter what, let's just use 10, we are explicitly telling Unity's render engine, hey, no matter what, always draw Barry on top of the background, which is still at 0. It's really that simple. Okay, so Barry is visible now, but he's still basically a ghost. If we hit play, he'll just fall right through the snow and into the abyss forever. That's because he has no physical shape. To fix that, we need to add a collider component, which is what defines his physical boundaries for the physics engine to actually see. Now, let me show you a little trick that's going to make your life so much easier. Trying to edit a collider on a shape that's already tilted is a huge pain. So before we even add the collider, I'm going to temporarily flatten out the snowboard. I'll select both child sprites, hit E for the rotate tool, and just rotate them until that board is perfectly horizontal. We'll rotate him back in a minute, don't worry. Now this next part is critical. Click off the children and make sure you reselect the main parent Barry object. The collider absolutely has to be on the same object that has the rigid body. All right, with our parent Barry object selected, I'm going to go over to the inspector and click that big Add Component button. In the search bar, I'm going to type Capsule Collider 2D. Now you might be asking, why a capsule and not just a box? Well, a box collider has sharp corners, and those sharp corners can get snagged on tiny little bumps in the ground. A capsule collider, with its nice rounded ends, is perfect for things that need to slide smoothly over surfaces, like, say, a snowboard. Let's click to add it. Okay, you'll see this default vertical capsule pop up. We just need to mold it to fit our snowboard. First thing, in the component settings, let's change the direction from vertical to horizontal. There we go, now it's pointing the right way. Next, let's play with the size. I'm going to hover my mouse over the X label, then click and drag to the right to stretch it out until it's about the same length as the snowboard. Looks good. Now I'll do the same for Y to control the thickness. I'll make it much, much thinner. And finally, you'll notice it's centered on our pivot, but the board is down below. So I'll adjust the offset Y value, dragging it down, down, down until that green outline is perfectly hugging the snowboard graphic. Done. Okay, the collider is shaped up. I'm going to rotate Barry back to his normal angle, and let's hit play. Let's see what happens. And yes, success. He lands right on the snow. He doesn't fall through. But hang on. Notice he's not moving? He's just stuck there. The ground is clearly sloped, right? Gravity should be pulling him down the hill. So what gives? And this right here is a really important moment in game development. We could spend the next hour tweaking physics materials, playing with friction and gravity settings, trying to get him to slide realistically. But here's the problem with that. His speed would be totally dependent on how steep the slope is, and that leads to really unpredictable gameplay. For a game to feel good, you, the developer, want to be in control. So for now, we're just going to accept that he's stuck. Later, we'll write a simple script that gives him a constant forward speed, which gives us much more reliable and fun control over the game. We are on the home stretch now. The very last thing we're going to do for our character build today is add a second collider. This one is not for sliding on the ground, though. We're setting up a special detection zone right around Barry's head. This is going to be absolutely essential later on when we want to write some code for crash detection and figure out when his head hits an obstacle. You know the drill by now. Let's select the parent Barry object, click Add Component, and this time, let's search for Circle Collider 2D. A big circle will probably appear right at his feet. It's way too big, so first, let's find the radius property and just shrink that down until it's about the size of his head. Then, just like we did with the snowboard, we'll use the offset Y value to move it up, and maybe nudge the offset X just a tiny bit to get it positioned perfectly over his noggin. Now, for the final and most critical step for this head collider. We do not want his head to be a solid object. If it was, he'd get stuck on ceilings and bonk into things. We just want to know when his head has touched something. And that is exactly what a trigger is for. In the Circle Collider 2D component, just find this little checkbox that says Is Trigger, and check it. That's it. This one click completely changes its behavior. It's no longer a physical wall, it's now an invisible detection field that will just tell our code, hey, I just overlapped with something, without actually causing a physical collision. And just like that, our character is built. Let's just quickly recap. We ripped out the old placeholder, we assembled a brand new character from multiple sprites using a parent-child hierarchy. We fixed all the alignment issues and the render order, and we set up two very different colliders, a solid one for sliding on the ground and a trigger for detecting head bonks. He is structurally complete. But the big question still hangs in the air. He looks the part, but he can't actually move. How do we give him speed? How do we take control and make him shred down that mountain? Well, that is the final piece of this puzzle, and it's exactly what we'll be tackling next time. Thanks for following along.